Okay, so here we have a diagram and it tells us that it's not accurately drawn. So the key point to note here at this stage is we can't measure anything directly from that diagram. So the question asks us, is BCD a straight line? Show working to support your answer. So this is line BCD and we're asked if it's a straight line. Now what you'll notice is the other lines, the other sides of this diagram where we've got some triangles formed have been labelled with expressions in terms of A and B. So these are vectors, guys. We're working with vectors. Okay, and vectors are simply directions, journeys you take from one point to another. What's important to note is the direction of the arrows, because the direction that the arrow points is the direction that that vector applies to. So if we move in the same direction of the arrow, the vector is exactly as it is. If we move in the opposite direction to the arrow, we're doing the inverse of that vector, so the signs need to change, guys. Okay, so is BCD a straight line? Well, at the moment we can't say anything about BCD. We've got nothing labelled. So let's start by finding the vectors that describe the journey for BC, and that's what this notation means, and C to D. So let's start with that. So to go from B to C, I have to map a journey, but that journey needs to be via a route that I know information about. So I'm going to do B to C, but I'm going to go B to A, and then I'm going to go A to C. Okay? So the journey would be B to A, so B to A, and then A to C. So now I'm going to write the vectors for B to A and A to C. Well, B to A, we know is 5A subtract 2B. I've got 5A subtract 2B, but then I am adding A to C. Now, A to C is going in the opposite direction to the arrow, so it's not 3A plus B, it's minus 3A minus B. So minus 3A minus B. So when I rewrite this, I have 5A minus 2B minus 3A minus B. So we're going to simplify this. I'm just going to move this down, guys. I still need it. Oh no, I can't move it. Okay, we're just going to get rid of it. I still need it. Let's rewrite it down here. Still definitely need it, but I need a little bit more space to simplify because I write massive. So we're going to simplify this vector for BC by collecting like terms. So we have 5A subtract 3A. 5A subtract 3A leaves me with 2A. And then we have minus 2B minus B. So we have minus 3B. So the vector BC is 2A subtract 3B. So we can write that on there if we want, and we're going B to C, so we're traveling in that direction. We're now going to do the same. We're going to find the vector for C to D. So the journey I'm going to take for C to D is a journey where I've got things labelled. So I'm going to go from C to A, and then I'm going to go from A to D. So C to A, we're travelling in the same direction as the arrow. So I'm going to do 3A plus B. And then A to D, we're travelling in the same direction. So it's exactly as it is, 3A minus 9B. So then we're going to simplify, guys, okay? Collect like terms. 3A plus 3A gives us 6A. B minus 9B gives us minus 8B. So that is our vector for CD. So now to decide if BCD is a straight line, we need to compare these vectors. So we've got BC equals 2A minus 3B, and we've got CD equals 6A minus 8B. Now, if BCD was a straight line, then BC and CD would have a common factor. They would be scalar multiples of each other, okay? So if we factorize BC and CD, well, there isn't a common factor I can pull out for BC, so it just stays as 2A minus 3B. But what I could pull out for CD is a factor of 2, which leaves 3A minus 4B. I have no common factor here, guys. No common factor. So I can't write them in terms of A minus B, for example, with them both having a factor pulled out. So BCD is not a straight line.